In this chapter, we are going to take a look at confidence intervals. So what confidence intervals are going to do, they're going to give us a way where we can take sample data, informations that we obtain through a sample, and try to use that to make informed inferences about the population. Before we get into that too much, or as we're developing that, we need to establish some terminology. Right? So the first thing that we will define is a point estimate. So a point estimate is the single value or point that we use to approximate a population parameter. So there are some cases where the point estimate is really pretty easy, pretty straightforward to get to. So we have, if we're trying to estimate a population proportion or a population percent, the best point estimate of a population proportion, P, is the sample proportion, P hat, right? So if we have a population proportion, we want to say, I want to know what percent of the population is in favor of candidate A. We could take a sample and say, well, we know in this sample that 47% is in favor of candidate A. And so from that, we could say, well, I would guess then that 47% of the entire population is in favor of candidate A. Now, that's probably not the exact answer, but if I can only choose one number, that is the best point estimate if we only get a single value. Now, if we're trying to find a population mean or estimate a population mean, the best point estimate for a population mean is the sample mean. So if I want to know what is the average weight of all jelly beans, what is the mean weight of all jelly beans, I could take a sample of maybe 132 jelly beans, find the mean weight for that sample, and I'd say, well, I know this sample has whatever particular value as a mean weight. That will now be my best guess if I can only choose one value for the population mean. Now again, that value is almost certainly not the actual value for the population mean, but if I only get to choose one value, that's my best guess. So what we do with this point estimate, we usually build what is called a confidence interval around this point estimate. A confidence interval, it's sometimes also called an interval estimate. This is, instead of having a single value, we get this range of values, and we use those to estimate the true value of a population parameter. Right? So that's what a confidence interval will do. We will often abbreviate this with a CI, so confidence interval. Some terms that we have associated with confidence interval is the confidence level. So this is the probability 1 minus alpha that the confidence interval does actually contain the population parameter. Right? So with that confidence level, when we are saying that it is 1 minus alpha, if we happen to have a normal distribution that we're building this on, and sometimes we will, sometimes we'll have something else, so that 1 minus alpha seems a little bit weird, but really what we're saying is here in the middle of this normal distribution, we're going to have an area of 1 minus alpha, and then in those two tails, we're going to have the other alpha, so half of it's over in that tail, and half of that remaining part of alpha is over here. So that's our confidence level. It's also called the degree of confidence or confidence coefficient. Right. So we're going to just work on really quickly, really easily. Let's look at a couple quick examples where we try to define or determine that value of alpha. So suppose we're asked to calculate a 95% confidence interval. What is the value of alpha? So remember, our confidence interval is 1 minus alpha. So 1 minus alpha is equal to 0.95. So if we add alpha to both sides and subtract 0.95 from both sides, we end up with alpha is equal to 0.05. So that's our value for alpha. If we have a 99% confidence interval, then 1 minus alpha is equal to 0.99. And so alpha is 0.01. Now I did get a little bit ahead of myself on this one because this problem doesn't ask what the value of alpha is. Instead it asks what the value of alpha over 2 is. So we found alpha. To get alpha over 2, we're just going to divide both sides of that by 2. So we get 0.05. Is our value of alpha divided by 2. Oh, no, that's not right. It's 0.005. Whew, that was close. .005. It's half of 1%. And if we look back up at this normal distribution that I drew above, that gives us some intuition behind what's happening there or why that might be of interest to us. Right? So overall, in just one of those two tails, we have an area of half of alpha. Between the two tails, the total area in the two tails together is actually alpha. So that's why each one of those things might be important to us in some form. And then the one other term that we'll define here at this moment is the margin of error. So the margin of error in estimating a population parameter is the maximum likely difference between an observed sample statistic and the true population parameter. So in many cases, what's going to happen with this margin of error, we're going to use that margin of error and subtract it from a point estimate and add it to a point estimate to generate this range of values. And that range of values will be our confidence interval. Now the one case, or at least one of the cases where we don't have something that quite goes this way, is when we have normal distributions, not normal distributions, when we have distributions that are not symmetric. When we don't have distributions that are symmetric, we are going to end up with a point estimate that is not right in the middle of the two ends of our confidence interval. So we're not adding the same margin of error to both sides. All right, in the next video, we will look at some more stuff dealing with confidence intervals. We'll talk specifically about how do we build a confidence interval for when we're trying to estimate a population proportion. And then in the videos after that, we'll look at some examples. All right, I'll talk to you guys later.